If you ask the internet, how do I learn to code? You usually get the same advice. Just build something. So you build a calculator or a weather app or a to-do list. But after you finish, you feel like this person here who says, I can't understand and can't do anything on my own. You feel like you just glued together some libraries and you're still stuck. You don't feel like a software engineer. I've been thinking about why this happens. Back when I was an undergraduate teaching fellow at my university, I noticed a pattern in the assignments that my professors gave out. The projects that actually made students grow, the ones that turned them from confused students into capable engineers, always shared the same DNA. They weren't just random tasks, rather, they were designed with specific constraints that force you to learn the foundations. Now, after 13 years in the software industry, I was able to isolate 4 main criteria that these professors would follow when it comes to coming up with these projects. Alright, now the first criteria is what I would call the no magic criteria. And what I mean by that is don't use magical libraries to build out your coding projects. Because if you just use libraries, the only skill that you develop from doing that is knowing how to use different libraries and put them together. But you don't really understand how programming works at a foundational level. For example, if you really want an awesome coding project, then you want one that forces you to handle the bits and the bytes of your data. Once you do a coding project that does that, then you'll have so much confidence when it comes to data and how to manage it in your program that every coding project that you're ever going to do after that will seem like a piece of cake. Now, I'm not saying that you can't use any libraries whatsoever. Of course, you can use some standard libraries, but what I'm trying to discourage you from doing is having your coding project be so heavily dependent on someone else's library, someone else's algorithms, that basically the real star of your programming project is the other developer. What you really want to do is you want to have a coding project where you're the star of your coding project, and especially if you're building a coding project where your primary goal is just to learn how to do software engineering, you want to build your own libraries and then you can use those libraries in your coding project. Now, I know in the higher level programming languages like C#, Python, and Java, they have a lot of standard libraries that do a lot of the heavy lifting for you. And I think it's okay to use those libraries as long as they're not the main thing or the main part of your coding project. You want your coding project to be able to do something complicated. You want these features to be something really meaningful. And then these libraries are just minor tools to help you achieve that outcome. But this is why I like to recommend that people code in C, because C doesn't really have these kinds of libraries. And so in C, you're forced to basically build your own libraries and have more control over the data yourself. And then when you have that experience in C, it really helps you appreciate those standard libraries in the higher level programming languages. All right, now the second criteria is structure necessity. And what that means is you want your coding project to have data structures out of necessity, not because you're just trying to play around with these data structures, but because your coding project can only work if it uses these data structures. Like, for example, with a to-do list app, you can implement a to-do list app with some data structures, but maybe all you need to have is an array to do that. But what you really want to do is you want to have a coding project where you're forced to use some complicated data structures like a binary tree or a priority queue. And then that really helps you think about how to implement these data structures, and that gives you a good foundation for your software development. What I noticed about the really cool coding projects is that they really forced you to feel the pain of managing pointers and linking nodes together manually. And that experience is really critical because it helps you have a fuller understanding of how data structures are created and how they work together. When I had this coding background, I was able to go into my first job and my second job, and I encountered all kinds of data structures there, but they didn't intimidate me at all because I already knew, I had an intuition on how they worked. And so, especially in the higher level programming languages, a lot of things that I did in C manually, they were automatically doing for you in these higher level programming languages. So this is what I was saying earlier. I was able to appreciate all of those libraries in the higher level programming languages because I felt the pain of doing them in C. All right, now for the third criteria, which I would call the architecture criteria. And this criteria means that your coding project has to be so complex that it couldn't possibly fit in just one file. Or if you're able to fit it in that one file, it would be a really long file, and it would just be so complicated and complex and just a pain to look at that you would have to split that file into other files. And basically what this really helps you do in your coding project is have a sense of how to architect your coding project, how to build it in such a way that there's some modular pieces to it. So you have one C file, or you have one file that's doing one thing, you have another file that's handling another thing. And this is important because when you start working with other code bases, especially in the software industry, when you start working professionally, you'll have code bases that are not going to be in one file. They're going to have tons and tons of files, and then you have to be able to navigate that code base. And that code base, they will link these files together in different kinds of ways. And if you have this experience of this architecture experience with this architecture criteria, then you have a intuition of architecture and how to put files together so that they are built together, and then how you can make sure that you can make your code more modular. And what I mean by modular is there are different modules that do different things in your coding project. I alluded to this idea in my previous video about architecture, and the main idea here is that coding architecture is also a skill in and of itself. So coding is a skill, but putting your code together, expanding on your code base, and making sure that you're able to understand your code base, even though it has tons of files, you're able to understand where everything goes. That's another skill in and of itself. All right, now for the fourth and last criteria, that is the tangible result criteria. And that means your coding project has to have a tangible result. It has to be a cool project where you have something physical that you can see, or maybe digital that you can see, that is really meaningful. And this will really help you with your motivation to finish the project. If you do a project where it's fun and there's some tangible result that you can see, that you can look at and you can say, wow, cool, I was able to do that, then that will really help you finish the project. So in other words, you want this coding project to be a fun project. And bonus points if you can get it to be something that can actually give you some benefit in your real life. If you have a coding project that will help manage or address a pain point in your life, then you'll have even more motivation to finish that coding project. All right, now that I've told you the 4 criteria, is there a project that satisfies all 4 criteria that I can tell you right now? And yes, there is. There's one coding project that I really like, and I think it satisfies all 4 criteria, and that is the Huffman compression engine. All right, this is my Huffman compression engine project, and we're going to go through the 4 criteria together for why this is a really good coding project. So before I do that, let me just explain what this coding project does. So let's go to terminal, and I'm just going to show you some files in my tests folder. So I have these 2 text files. This is a really big text file, and that's because if you can actually look at it, it's the Les Miserables ebook. So we have this Les Miserables ebook. It's a long text file, but what this coding project does is it compresses it into a smaller file, and then with that compressed file, we can decompress it and decode it, and we can recover the original file. So this is a really cool project because it helps you save space in your computer, and we know this in our practical experience. Compressing data is really valuable, and so this satisfies the 4th criteria for why this is a fun project. And it's really fun when you are able to encode a Huffman file and then decode it and be able to recover your original file. When you have that working in your coding project, then there's a lot of satisfaction, and you have this sense that you built something really cool. So that's the 4th criteria. Now let's go into the 1st criteria. So the 1st criteria is that we're not going to use any magic libraries. So here you can see we implemented a lot of different things for our coding project. We didn't use someone else's library. We had our own library. And not only that, but we also had to deal with data, like data itself. And so part of this project requires looking at all of these characters and see how often they show up in the program. So we had to create a frequency.h where we are able to store the frequencies for each of these characters in our file. So that involves understanding ASCII. So you're forced to understand how ASCII works with this coding project. And then also with the encoder and decoder, in order to encode and decode files, you have to process it from a bit level. So when we encode files, for example, in this Mississippi text file, this is a really simple example. It's just these characters, MISSISSIPPI. And basically what we do in Huffman coding is we map each byte or each character to a bit stream. And we create that bit stream from the frequency analysis of all of these characters. So that's criteria number one, no magic libraries. We don't have magic libraries. We're doing all the heavy lifting ourselves, and we're also processing data at a bit and byte level. So that's criteria number one. Criteria number two is the data structure criteria. So you can see here we implement a binary tree and a priority queue here. So here's an example of the data structure that you may implement with this coding project. So for the Mississippi.txt file, you're going to implement a Huffman tree that looks like this. And with this Huffman tree, we're able to generate these codes for each of these characters. And basically, we take the M here and then we encode it with this 100-bit code. So that's why M becomes 100 here. And then the I is encoded with 11, and that's generated again from this Huffman tree. I'm not going to go into the details on how this all works, but basically this Huffman tree will generate 11 for the code for I, and then so that's how you append the 11 here for this bit stream. And so you get the idea here. We're able to make the Mississippi.txt file smaller because we are encoding it with just bits instead of full bytes. So that's criteria number two, data structure necessity. So here's the header files for those data structures. And then now criteria number three, of course you can see here we have so many files here. We have our main file here, but we also rely on other files to implement different parts of our coding project. So we have the decoder part, the encoder, the frequency analysis part, and then the data structures part. And then I also have a utils.c file here that will just help us with some utility functions for our project. And then of course we have our makefile here. So this makefile helps compile all of these C files together with the header files, and then we create our executable here in the bin directory. Alright, now for the fourth criteria, and I already mentioned this, but basically we are able to create a encoded file that's smaller than this, and then we can recover the original file from that encoded file. So I'm just going to show you it in terminal. So here we have our Huffman binary, and we use -c to encode this text file. So we do that, and then we create this Huff file, and you can look at here, and then you can see here that the IDE doesn't even want to open the .huff file because it's an encoded file, so it doesn't really make much sense to look at it. And then we're going to decode it. So we're going to use -d for decode, and then we're going to put in our Huff file here, the Huffman file, and then we do that. And then we decompressed it, we decoded it, and so we have our decoded file here. So look at the hash for these files. So we do the hash, and then we compare the hash, and they're the exact same. So this is how we know that we're able to recover our original text file from this encoded file. And then let's look at the size of these files. So this is the fourth criteria. This is where you're going to say, wow, look what I did. So we had this original file, this is the size, but then when we compressed it to a smaller file here. And so you can see we're able to save space in our computer because we have the compressed file here. We could delete this text file here, and it would be okay because we can easily just decode it using our program. Okay, so that's just a little taste of my Huffman coding project. But the cool part here is I'm also inviting you to build this Huffman coding project also. So I want to invite you to my program, the ProDev Sprint program. And basically we just build this project in four weeks, in 4 phases. So we do the frequency analysis first in the first week. Second week is going to be the architecture. So we build our Huffman tree. The third week is the encoding. So we encode our file, we create that Huff file. And then the fourth week, we decode that file together. And so the part about this program, I'm not going to give you the code. You're going to develop the code yourself, but I will give you some of the header files and give you some ideas. I'll also give you a video and the spec sheet on how to build this project week by week. And another thing about this ProDev Sprint program is that we're going to be using a Discord server where we can communicate. So if you ever get stuck, if you have a segmentation fault error that you need help debugging, I'm always there. You can ask me any questions. I'll be in the Discord server answering questions. And then there's also other students who will be in that server. So you can also ask them questions and then bounce some ideas together. And then lastly, you're going to turn in your project through the Discord server. So you'll create pull requests in GitHub, and then I can review your code every week. So every Friday, you just turn in your code, and then I'm going to review your code and point out anything. And then you can look at my comments and then you can fix your code. And don't worry, I'll be with you the whole time, so I'll ensure that you actually finish this project and that you're able to actually code this cool coding project. So if you want more information about that program, you can check my website, henrikmdev.com/sprint, and then you can see more details there. Alright, that's it for this week's video. Thanks for making it to the end. If you have any other ideas on what would make a coding project really awesome, any other criteria you would want to add, let me know in the comments section, and that would be really cool to see. And of course, check out my program if you really want to build a project that satisfies all 4 of these criteria. Check out my program. And if you have any other questions, feel free to let me know in the comments section, and I'll be sure to answer you there. And I'll see you in the next one. Peace.